Math 265A, Cuesta College. I'm Joe Vasta, and we are going to cover Bug 5, classwork. What we have is a bug is moving on a number line. Remember that T is time in seconds. That's the input, so there's the t-axis, and the output is s, which is position, and this is feet from the origin on a number line. So a bug, here's the bug, he's moving on a number line, and this graph here, f of t, and it comes down like this. It is a function, goes like this, and comes up there and goes up there. There's some other lines on there, and we'll talk about those lines pretty soon. Okay. F of t describes, so it looks like this, and we say f of t equals s. Okay, so that's f of t equals s describes the position, like we said. For each point, and there are 2 points here. Here's one point, there's the other point. Find the bug's time, position, and instantaneous velocity. So we found out in bug 4 that the instantaneous velocity is gotten by finding the slope of the tangent line. So there's 2 points. We're going to start at the point 1, 2. So this is the first one we're going to do. 1, 2. And there's actually 2 points we're going to do. And 1, 2. So for each point, find the bug's time. Okay, so the time is the first coordinate, the input, which is 1 second. Find the bug's time, the position on the number line. So the position is s, which is the output, the second coordinate. The bug's position is 2 feet. Okay, the third thing we want to find at time 1, or at this point, is the instantaneous velocity. The instantaneous velocity, we'll just use v for that, and that's going to be the slope of this line. So if you forgot how to find the slope of a line, let's go over it. You go ahead and you pick a point on the line that is the intersection of 2 grids. So here's a point, and then we have that point, and you do rise over run. So rise 1, 2, 3 over run 1. So 3 over 1 is 3. So the instantaneous velocity at this point right here, 1, 2, is 3 feet per second. And so we have just finished the first point. And that it describes a lot. It describes the time, the position, and the instantaneous velocity. Sometimes the instantaneous velocity will just be called the velocity. Okay? Now when we're talking about average velocity over a time interval, we'll say average velocity. But instantaneous velocity, we can either say instantaneous velocity or just velocity. Let's do the next point. Now it looks like that was a point on there, but I just drew that to find the slope. The next point would be this point down here, which is the point -2, -3. -2, -3. Okay, let's go find the time at that point. Well, the time is the input, which is -2 seconds. Find the bug's position, which is denoted by s. Well, his position on the number line is -3 feet. Now, what does that mean? He is 3 feet to the left of the origin, or he's at -3 on the number line. At time -2, -2 seconds means 2 seconds ago. Well, what is the bug's velocity, or the bug's instantaneous velocity? Well, we look at the slope of this horizontal line. You can put another point like right here. Rise over run, rise is 0, run is 3, 0 over 3 is 0, and we have to put our units feet per second. So if you pretty much get this and think it's a breeze, then bug 5 is not going to take you that long. It's going to be pretty quick. And what we want you to get out of bug 5 is instantaneous velocity is described when you have a position function graphed using the slope of the tangent line at the point. So this concludes bug 5, and our next section that we're going into is 2.1.